Hello everyone, welcome to my video clip. Today I want to discuss about differentiation of exponential function. In particular, differentiation of this exponential function. You must know the general form very well. E to the power fx. If you differentiate this, it will be just differentiating the power multiplied by the original function. So that's a general formula. Please take note that this formula is not given in the formula sheet. What is given is very basic. So if you're going to rely on the basic formula sheet, you won't see this thing appearing there, the f prime x. So on the safe side, always good to memorize. Alright? And to continue, what we need to do is, in this particular question, let's analyze it. You notice that they give you the exponential function of this form, and they want you to express this exponential function in terms of ex ln 2. They want you to use this form actually. Use this form to derive this answer. So what you need to do is write out the function first. Y equals to 2 power x, and your given is e to the power of x ln 2. Alright. Now if you want to write the ln 2 in front, then you should write it this way. You have to put a bracket there. Okay, if you see in this form, probably you remember how to differentiate straight away. So to differentiate this exponential function, we actually differentiate the power. The power is ln 2 bracket x. There, that's what we have. And then multiply by the original function, which is x ln 2. Once you're finished doing that, differentiate this will give you ln 2. Now be very careful, always put your ln 2 in bracket and then multiply by this function here. If you look carefully, ex ln 2 is the same as 2 to the power x. So we can change it back to the original form. Right, so we have that. Or we can rewrite in the form that the question requires it, which is 2 to the power x ln 2. So that's about the first part, A. For the second part, you ask to find the gradient of the function y equals to 2 to the power x squared here. So this is a little bit different now, but the same formula applies. So what you can do is do the same thing using the same formula. It means we expect it as an exponential function. So this will be e x squared ln 2. Okay, and the same thing you apply here. We differentiate the power. In this case, the power is actually x squared ln 2, and then multiply by the original function, which is ex squared ln 2, or 2 to the power x squared. So differentiate it straight away. You will have 2x ln 2. Remember that ln 2 is a constant. Multiply by this. Okay, once you've done that, the next step is just to substitute in the coordinates. In this case, the x coordinate, because the differentiation only depends on the x value. So at this point, 2/16, your dy dx will be equals to, we place the x, we have this, we have ln 2, you've got to be careful, always put a ln 2 in bracket, and then 2 to the power of 2 squared. Simplifying, 2 squared is 4, 2 to the power of 4, 16, 16 on 4 is 64, so you end up with 64 ln 2. So that's the final answer. Okay, just to recap, the most important part is this part here, the part A. If you're going to use this form if this is a form that's required to be used, you must use it. You cannot do any other way. If you do any other way, then you're not following what the questions require you to do, and you will lose mark even if you get the answer. Alright, unless your method is legitimate, but they want you to use this. Okay, and the second part is just it's exactly the same thing. The method is exactly the same. Only thing is your function instead of x becomes x squared. So again, if you apply this formula, we differentiate the power first. Most students get confused because when they see this, they don't know what to do. They saw the ln 2 there, forgetting that the ln 2 is actually a constant, so it shouldn't affect you. It's just a factor of the expression. Alright, that's all for today. Thank you for watching. Bye.